Good morning students. So in this class we are going to discuss about power in an AC circuit. So power in a circuit is defined as a rate of consumption of electrical energy in a circuit. So already we know power is defined as a product of voltage and current. Here alternating current in a circuit. So alternating voltage and current. So that voltage and current varies continuously with respect to time. So first we are going to find what is the power at that instant, then that power is average over a complete cycle. So that is a complete cycle for that is a base length 2 pi. So power at that instant is find out first, then power that is average over the complete cycle. So first power, that is voltage V is equal to Vm sin omega t, then current Im sin omega t plus pi. So this is a circuit for RLC for inductive circuit. So for inductive, that is sin omega t plus pi. So power equal to voltage into current, then substitute the values Vm Im sin omega t into sin omega t plus pi. So here sin A plus B. So sin A plus B equal to sin A cos B plus cos A sin B. Then substitute A as omega t, then B as pi. So sin omega t cos pi and cos omega t sin pi. Then multiply by sin omega t. So you will get sin omega t into sin omega t sin squared omega t cos pi. And plus sin omega t cos omega t sin pi. So we are going to we find that power at that instant, then the power is average over a complete cycle. So with respect to time, so we take sin squared omega t and sin omega t and cos omega t. So first, so P average equal to, so integral from that is a 0 to 2 pi. So that is a limit for a complete cycle. So 0 to 2 pi sin squared. So take theta, that is omega t as theta. So sin square theta d theta divided by 2 pi. So 2 pi is a base length of a complete cycle. So take note that 2 pi, that 1 by 2 pi, integral 0 to 2 pi, then sin square theta equal to 1 minus cos 2 theta by 2. So again take that 2. So 2 into 2 4 pi. So here 1 d theta, that is d theta, then minus cos 2 theta d theta. Then so integral d theta equal to theta, then integral cos 2 theta equal to sin 2 theta by 2. So upper limit minus lower limit. So lower limit, that is 0, that is upper limit, substitute 2 pi instead of theta you will get 2 pi, then minus sin 2 into theta equal to 2 pi. So 2 into 2 4 pi. So sin n pi equal to 0. So already we know sin n pi equal to 0. So the total term is 0. Then after that, then theta equal to 0, then sin 0. So all the terms are 0. So balance, so pi cancel. So 2, so 1 2s are 2, 2 2s are 4. So finally you will get 1 by 2 for the first term. So instead of sin squared omega t, that is average over a complete cycle, that is 1 by 2. Then the second term sin omega t cos omega t. So again P average, that is 0 to 2 pi sin theta cos theta d theta, the phase length, that is the base length, that is 2 pi. So consider sin theta as t, then dt equal to cos theta d theta. So we need to change instead of t dt, so that limit also we need to change. So theta t, so if theta equal to 0, so substitute theta equal to 0. So sin 0 0, so t is equal to 0. Then theta equal to pi, that is 2 pi. So sin 2 pi equal to 0. So the limits, upper limit and lower limit, both are zeros. So P average equal to 1 by 2 pi, that is integral 0 to 0, then d dt. So integral d dt equal to d squared by 2. So totally it's 0. So the second term it's completely 0. The first term, that is 1 by 2. So the P average is equal to that Vm Im 1 by 2 cos pi. So that 2 is split into root 2 into root 2. So Vm by root 2, Im by root 2. That Vm by root 2 is Vrms, then Im by root 2 is Irms into cos pi. Then so that Vrms Irms is equal to, that is apparent power. So cos pi is a power factor. So we can write it as P average is equal to apparent power into power factor. So P average is also called true power of the circuit. So P average is also called true power of the circuit. Some special cases are discussed here. If pi is equal to 0, so substitute pi is equal to 0. So cos 0 1. So that is the circuit is purely resistive circuit. If pi is equal to 0 means the circuit is purely resistive circuit. So P average equal to Vrms Irms. Then pi is equal to plus or minus pi by 2. So plus or minus pi by 2 means pi is equal to pi, that is cos pi by 2, cos 90 equal to 0. So the circuit is capacitive or inductive. So that is P average is equal to 0 for If it is the circuit is capacitive or inductive, P average is equal to 0. If it is resistive, Vrms into Irms. Then the third case, so that is RLC circuit. So pi is equal to tan inverse of XL minus XC divided by R. Then P average is equal to Vrms Irms into cos pi. Then final one at resonance. So at resonance that pi is equal to 0. So because XL minus XC, that is XL equal to XC at resonance. So that is totally 0. So pi is equal to 0 for resonance. So P average is equal to Vrms into Irms. That is purely resistive. So these are the 4 special cases. So in this class we have discussed power in an AC circuit. So power in an AC circuit is defined as the rate of consumption of electrical energy at that circuit. That is, that power is a product of voltage and current. So we are doing something, then power at that instant we found out first, then that power is average over a complete cycle, that is a 2 pi. Then finally you will get P average is equal to Vrms Irms cos pi. Then Vrms Irms is equal to, that is apparent power, then cos pi is power factor. Then the special cases, pi is equal to 0 means the circuit is purely resistive, pi is equal to plus or minus pi by 2, the circuit is purely capacitive or inductive. Then for RLC circuit, then finally at resonance pi is equal to 0, we will get P average equal to Vrms Irms. So okay students.